In this module, let's talk about blockchain analytics. But before getting into that, what is a blockchain? A blockchain is a tamper-proof ledger organized into a series of linked blocks containing data. These blocks are added according to a set of special rules known as a consensus algorithm. So what happens is this enables networks of physical computers to work together, forming a single large virtual computer. Blockchains are distinct from other computer networks because 1. They are permissionless. Any computer anywhere in the world can become a part of this large virtual computer as long as they follow the consensus algorithm. In a blockchain, the blocks themselves can be thought of as the computer hard drive. The consensus algorithm is like an operating system, like a Windows or a Mac OS. And the peer-to-peer network is like the silicon semiconductor circuits that carry data between different parts of the computer. But unlike a traditional computer, a blockchain-based computer can offer strong trust guarantees rooted in the cryptographic and game theoretical properties of the system. For example, a user or a developer can trust that a piece of code running on a blockchain computer will continue to behave as designed even if individual computers in the network try to subvert the system. Thus, a blockchain-based computer enables disintermediate, peer-to-peer transactions, interactions, and digital services that are owned and operated by communities instead of corporations. A block is like a folder that contains files. The contents of this folder are the transactions that occur over a given time interval, and these are hashed by a cryptographic digest. Each block contains a reference linking to the previous block, which is why it's called a blockchain. Blocks are added by the miners or validators on a crypto network according to the consensus protocol. They check 1. To ensure balances are not spent twice, that each digital signature matches the public key of the message, and more importantly, the included reference matches the hash of the previously added block. Because blocks are made of cryptographic digests, they cannot be changed after the fact without being detected. So blocks are effectively immutable once added to the blockchain. Nobody can change the transactions. A ledger. What is a ledger? A ledger is just a list of transactions. It is like an account book. These transactions need not be just payments. They can be anything. They can represent transfers of any assets, such as like a real estate deed or an interest-bearing security, anything. A blockchain fundamentally is a tamper-proof ledger. It's an account book. Because each ledger transaction is a cryptographic digest, that is, the information is secure and entry cannot be altered without detection. More importantly, by hashing and turning the entire ledger into cryptographic digest, any addition, alteration or omission of any transaction will change the cryptographic digest of the entire ledger. Thus, blockchains enable participants to audit one another in a decentralized manner, so you don't need one centralized authority for that. That is the beauty of a blockchain, and how do we perform analytics onto that will come in the next module.